The new AI SDK is available in OpenMetadata version 1.12. As part of that release, we have a Python MCP integration that lets you interact with LangChain, OpenA, and the like in a more ergonomic way. All of this is available in the Metadata AI SDK on GitHub. If you take a look at the cookbooks we have, for example, this MCP impact analysis leverages that. Looking at this sample Python script, it's built on top of LangChain. You would define and build out how this agent needs to behave, and as you can see, we connect to a specific server, use the OpenMetadata SDK to interact with some of these MCP tools from OpenMetadata, and pass those tools into the agent, allowing you to easily take advantage of the knowledge in OpenMetadata from your own tools using semantic intelligence. All part of the AI Studio and AI integrations that are now available. Also in version 1.12, we've enhanced data quality rules and tests in several ways. First, a little background on the process before this update. Prior to implementing the test library, if you were to run a data quality test, you would be limited to what was provided natively in the application. While these tests are quite powerful, they made it more difficult to create a custom test. You could of course write a custom SQL query, but implementing and testing that at scale across multiple databases or even making it available to non-technical users can be problematic, requiring you to provide the query to the business user who would then have to know where to go and copy-paste it to use it. This action would have to be replicated for every table you wanted it to apply to. With the introduction of the rule library in version 1.12, we are accomplishing a few things. The first is to control which bundled data quality tests are available. You can enable or disable any of these tests with a simple toggle. That's our first change, the ability to control which test cases are available for a user to execute. Our next big change with the introduction of the rule library is the ability to add a new test definition. From the same rules library, we click to add a new test definition. Give it a name. We can provide an optional display name if desired. The description is mandatory. And now we have the SQL query section, and this is where the magic happens. This is going to be a column level test, so we use double curly braces around the reserved word column_name. This system variable resolves at runtime to the actual column name the test case is linked to. Similarly, on the from clause, we'll use the double curly braces around table_name, which also resolves at runtime. For our where clause, we're going to define an argument. This is an argument that the user can set when applying the data quality test. So this is our data quality test template now. To finish filling out this test definition, we select if this will be a column or table level test. We'll set that to column. Then I can associate it with a data quality dimension, such as completeness, accuracy, consistency, etc. Now I can restrict this to a specific service or set of services, or make it available to all of them. We'll go ahead and select Redshift. We can even restrict it to the data type that you want the test to be available for. We'll just make this available to numeric types of columns. For the parameter, we want to associate it with the argument that we defined in our SQL earlier. We can then give it a different display name if desired, and we'll see how that applies later. Then the data type it will be, in this case, an integer. You can see that multiple parameters can be defined, but we're only setting one. We'll make it required, and then we'll save it. Going back to our Redshift table, we have a few integer fields such as customer ID and customer lifetime value. So those two will have that new test definition available. Let's go to a column level test, then select the customer lifetime value. Then in the test type, if we scroll down to the bottom, we'll see the test definition we just defined. Now we see the myArg field, which displays the display name we specified, and the red asterisk indicates it is required. The value we put here will get resolved in the SQL query we defined for the test, just like the table and column name will be. We'll put 20 as a value, and then we'll create the test. What we've illustrated is just how easy it is to create a new test template with dynamic variables that can scale easily across your organization and be utilized by your business users with ease. Release 1.12 introduces a new governance capability called column bulk operations. Organizations generate data in many ways, from APIs to databases such as MySQL, Postgres, Oracle, and others, eventually landing in an S3 data warehouse and then being presented in your data dashboards. Even search indexes are included in this ecosystem, and OpenMetadata brings all of this metadata under one roof. Now that you have all this metadata, how do you identify the commonly used columns across those disparate systems? And how do you maintain the documentation, the governance classifications, the glossary terms across these identical column names in different structures? That's exactly what column bulk operations is going to help you with. It identifies all of your unique columns. For example, in this instance, we have 1,770 totally unique columns, but they appear almost 500,000 times across your data infrastructure. Now, instead of going to each asset and trying to update these one at a time, you can go to column bulk operations, update these columns, and have it reach all of these different assets in one go. It also offers lineage-level propagation, where the lineage-level propagation appears as the column changes shape and form over the lineage. This gives you a bird's-eye view of all your columns. You can filter by name, for example, search for customer, or search for address. You can see columns marked inconsistent, meaning some columns have descriptions and others don't. We can select these and click Edit, and give them a meaningful name and description. We can choose this to be PII sensitive, add address as a tag, assign it a glossary term of customer, and then I can update all of these assets in one go. As you can see, it applies the same definition, name, descriptions, and glossary terms across all instances. This gives you everything to understand your data consistently, no matter what it's called, no matter where it exists. As long as it has the same name, you can manage that in one go. Now, there are several other utilities built on top of this. The first, how do you find columns that are missing data? You can see all of these columns have no metadata at all. From here, we can set various filters, so let's choose incomplete. This shows us what columns are actually incomplete. For example, you may have 4 columns, but they don't have consistent metadata. Some have descriptions, some have tags, some have classifications. Now let's try filtering for inconsistent data. Thankfully, we didn't find any inconsistent columns. Inconsistent means there is data on some columns that doesn't match. For example, you might call this user address in one place and customer address in another. Inconsistent means the descriptions don't match, the tags don't match, or the classifications don't match. You have various different filters to look at the domain level data. Maybe you only want to look at specific services like Snowflake or BigQuery. If you have a specific scope that you want to focus on, you can filter on that as well. This gives you amazing new capabilities to manage your metadata at a higher level. Come try it for yourself.